So here we are, welcome to the paper 3 for Edexcel June 2023 series. It's paper 3, so calcs at the ready. So to begin with, we've got some laws of indices questions. Don't forget for the first one, power to a power would mean multiply the power. Part 2, B, add the powers. Straightforward, multiply means add. And here, expand. So p to the 1 times p to the 2. You get p cubed. And 4 times 3 is 12. P times p is p squared. Number 2, good old wordy one. Here we go. Johnny wants to know 800 people. So, one line at a time. 800 people, each person 2 cups of coffee. So the running total so far is 1,600 cups. 10.6 grams of coffee for each cup. Let's multiply. So 1,600 times by 10.6. I'm getting 16,960 grams of coffee. Johnny assumes 68% of people drink the coffee. In other words, only 68% of the coffee will be used. So we times it by either 68 over 100 or 0.68. Nearest gram, well, I'm getting 11,532.8. So 11,533. No need to fill space just because it's there. Johnny's assumption is wrong. So more people drink the coffee. How does this affect your answer? Well, if more people are drinking coffee, more coffee is consumed. So any words to the effect that your answer will increase will get you the single mark. As always, 1 mark. It's not worth 3 lines. Keep it simple. Show that something's isosceles giving reasons. Well, let's come to the isosceles bit later on. All right, ACD is the triangle, so we're focusing on all the angles up here. So I'll not write out each reason, I'll just say them out loud. First of all, if that's 110, you've got a 70 inside because the straight line makes 180. If that's 125, so's that, because corresponding angles are equal. And if that's 125, this interior is 55, because again, straight line's 180. And we're down to the 3 angles in this triangle, making 180. 180 take away 70 is 110. Take away 55 is 55. Show that it's isosceles. Well, if you've got 2 angles the same, you've got a line of symmetry, 2 sides the same. However you want to go about that, it's entirely up to you. Number 4. 14 hours, 5 pumps, 14 fives. That's 70 work hours, whatever you want to call it. How many hours would it take 4 pumps? So 70 divided by 4. Halve it, 17.5 hours. We like those questions. Number 5. Highest common factor and all that malarkey without doing the trees. But they have done the ends of the trees, the ends of the branches, and your HCF is multiplying what's in common. So what can we see in common? Well, there's 3 squared in each, and there's a 7 in each. So that's 9 sevens, 63. That's the HCF. To find the lowest common multiple, you multiply it by, I always call it, the leftovers. What's left behind? Well, there's two twos, there's 2 squared, there's a 3 squared, and there's a 7 also left over. So grab your calcs, 63 times 4 times 9 times 7, getting a tiny answer of 15,876. On we go. Number 6, lava flows from a volcano. Now, at the end of the day, it's all about dividing and converting. It wants the answer in days. So just keep a running total of where you are. So if you take the 67,000, 67 million and so on, divide it by 11.9, that will tell you how many seconds. So 67 million, don't be daft out, 205,600. And we divide it by 11.9, getting a horrible decimal. 5647,529.4 and so on. But that's in seconds. If you want to convert it to minutes, divide by 60. To hours, divide by 60 again. In other words, divide by 3,600, and to go from hours to days. And there we go. So I've left that number in my display, divided by 3,600, divide by 24. My horrible answer is 65.36, but it wants nearest day, so you don't have to keep going. Nearest day is 65 days. Number 7. Easy. If you've got your knowledge of your graph, make sure you revise it. Mark scheme for B always allows a bit either way. Obviously, you're normally allowed half a square or something along those lines. Turning point, vertex of the graph, easy to read off, it's 1 minus 3. Estimate one of the roots. Let's always go for the positive, as we can see. It's just above 2.5, so anything like 2.6 or 2.7 will get you the marks. Down here, it's just below minus 0.5, so if you wanted to go that route, something like that will be fine. Rate, grams, centimeters cubed, mechanote, good old DMV. Work out the mass. So to work out the mass, it's density times volume. And that's it. So we've got 9 times 72, 648 grams. Keep them like that. Number 9. Wordy, but as always, one thing at a time. Some people were asked, we don't know how many. 70% of the people said yes, 80% of those. What percentage want a television with a large screen? So 70 out of 100 people said yes, and 80% of them said yes. So that's the calculation. You could do a decimal version, no one cares, but it's 56%, 56 over 100, or however you've worked that out. Number 10, it just screams trigonometry, screams SOHCAHTOA. Work out the length of D to C. I always like to stick an X on it. Now, the only way I can find out X is by knowing one of the sides. And the best side to go for, if I find AC, we're there. So let's focus on the first triangle. We've got hypotenuse, and we've got opposite to find. We've got the angle. Opposite and hypotenuse means it's a SO. So we've got opposite, which is y, is going to be the sine of the angle, which is sine 41 multiplied by 6.8. Wants the final answer to 1 dp. So give this to 2 or more, but not loads. So 6.8 times sin 41. So I'll go with 4.461. So that's this. So let's focus on the left-hand triangle. Opposite, adjacent wanted, that's SOA. We want A, so we need to do opposite over, in other words, divided by, that's a 1 by the way, divided by T, which means tan of the angle. Well, I've left them in my calculator, so let's just hit divide by tan 55. I'm getting 3.123 and so on. 1 decimal place, 3.1. So for number 11, too easy to waste time with an electronic pen with me being rubbish at it. So I've just taken the information and slotted it on. Job done. All right, just make sure you don't overcomplicate. Don't worry about how wide your lines are. No one cares. Just put all the numbers in. There's no puzzle there. It doesn't tell you the IQR or the range. It's just straight up put a notch on each one. And I'll just read you through B. When it's worth 2 marks, make sure you don't make 2 comments that fall into the same category. So if you want to compare the interquartile range with the interquartile range, that's fine. Say that they are either one's bigger than the other, or they're equal. But don't then say for your second sentence a comparison of the range. Although comparing the range is valid, you don't want to be comparing 2 measures of spread. So make a sentence, do a calculation if you want about spread, but then make a comment about median. So median is the compulsory, interquartile range and range, they're the one you take a choice over which one you go for, but keep them in different categories, 1 mark per category. So for number 12, typical cubic. Before you do a cubic, do the quadratic. Pick any 2 brackets, x times x, -1 times -3. Negative x is that loop, positive 3x simplifies to 2x. So I always prefer to do loops for stage 1 and block it up. Do area, whatever you want to call it, grid method for stage 2. So top row, let's times everything by x. So x cubed, 2x squared minus 3x. Bottom row times everything by -5, so minus 5x squared minus 10x positive 15. Now we simplify. X cubed is the only cubic term, plus 15 is the only constant. This diagonal, -5 plus 2 is minus 3x squared. And here you've got 2 negatives making a bigger negative. Minus 10 take away 3 is minus 13. On we go. Strange looking one here. So let's assume that this is our starting nth term. The n that comes after n is n plus 1. So this n becomes n plus 1. This n plus 1 becomes n plus 1 plus 1 all over 2. Easy to add because the denominators are already identical. So let's expand this first bracket, n squared plus n. Let's expand this quadratic, double brackets. You get n squared, you get plus 3n, and you get plus 2 on the end. Let's simplify the top. 2n squared, 4n, and 2 on the end. They all happen to be multiples of 2. So we can divide everything by 2. And oh, look what that is. If we factorise this, it's n plus 1, n plus 1. Bosh, it's indeed a square number. On we go. So number 14, bit of a mishmash here of two shapes. Calculate the area of OBC. In other words, the sector. Now, in order to work out the area of the sector would be pi times the radius squared times by the angle out of 360. So there's your logic. We don't know r, but we can work out r because we've got 9 split by 6. In other words, we have the cosine rule. Feel free to flick ahead or back or look it up, but I'll just quote it and use it straight off. So r squared will equal 9 squared, 81, plus 6 squared minus 2bc, in other words, 2 9s times 6s, 108, cos the angle that splits them. So let's grab the calc. 81 plus 36, take away 108, cos 35. And we're getting horrible decimal 28.5315, and it goes on. And obviously we are square rooting that answer. So I'm going to work with the radius being 5.341, which, as you can probably tell, goes into here. So the area of the sector is pi times this radius squared multiplied by 80 3/60ths. So we've got that number already in our calc. Let's just press squared. Let's times it by pi. Let's times it by 80, divide it by 360, and we're getting, it wants 3 sig figs. I'm getting 19.918 and so on. So that'll be 19.9. 15a and b, they don't look quite straightforward that they're linked, but they are. So 15 just needs factorising. It's not a standard difference of 2 squares, but that's what it is. And that leads you to here. How on earth can 2 to the 40 be a square number? You know, you could press it in your calculator, but it's going to spit it out in standard form. It's too big. Here's the key. 2 to the 20, because square root is power of a half. Half of 40 is 20. So difference of 2 squares for this is 2 to the 20 plus 1, 2 to the 20 minus 1. So as you can see, 2 consecutive odd numbers, 2 to the 20 will be an even number, a huge even number, and 2 to the 20 will also be even. So whatever how big it is, it's even plus 1 multiplied by even minus 1. So it's the even number, up 1, down 1, and you can put it in whatever words you want, but that's the crux of it. Number 16, yeah, I've cheated because me and technology don't mix. So centre enlargement, easy to label. How do you do a negative scale factor? Left 4, multiply it by a negative becomes right, and 4 twos are 8. So 2, 4, 6, 8. Any movement down becomes a movement up. And if your teacher nags you that you should be using raise, that's fine. But I always use raise as a way of double checking that they're in the right place. I prefer to start by counting, sort it out by counting, and check using raise. Also cheated for number 17, because again, no one wants to watch me mess up 3 or 4 times. So it says 2.5, so there's my line. Any tangent, and I just try and make mine have nice numbers, nice-ish, because it is an estimate. So I've got this triangle. My height is 40. My guessed width, that's about 3.6. That's about 1.4. So the gradient is, for me, is 40 divided by 2.2. So I'm getting 18.2. Give or take will be a right answer as long as it follows through from your graph. What does the gradient represent? Well, as you can see, if you're doing distance in time, as a distance time gets steeper, it means it's covering more distance. It's covering a greater distance in the same amount of time. So what does the gradient mean? It represents the speed. Number 18, calculator papers love a frustum, so here we go. Now, as with most of these, the main spot, always look for similar triangles, because in order to work out this frustum, you're going to need to use this radius here. There's your problem. The good news is you've got the 3. So what happens to 10 to get to 6? Okay, well, it's been multiplied by 3/5. All right, if you wanted to check that, do 6 divided by 10. So the multiplier from large cone to small cone is a multiplier of 3/5. 3 times 3/5 means the radius here is 9/5, or in other words, 1.8. So, how do we now work out? It says the slant height is 6, it's on the diagram, it's on the diagram, it's on the diagram. Total surface area of the frustum. So, let's do the easy bits first. Top circle, just a circle. It's pi times the radius squared. I'll get my calc in a sec. Bottom circle, the base, pi times the radius squared. Now comes the curved surface area. It needs to be big cone minus small cone. Big cone is pi radius slant. Small cone is pi radius slant. So let's start bashing the calc. Pi times 1.8 squared. It wants the answer to 3 sig figs, so I'll work in 4. So I'm getting 10.18. For the bottom, it's 9 pi. I'm getting 28.27. Here, I'll shorten things up because that's 30. Take away 6 lots of 1.8, that's 10.8. And obviously then we can just multiply it by pi. So the curved, I'm getting as being 60.31. Add all these together, 60.31 plus 28.27 plus 10.18, and I'm getting 98.7572, etc. 3 sig figs, 98.8 centimetres squared. So number 19, it's just a 1 marker. So we've got the graph of y equals 3 to the x. Well, kind of. Write down one thing that's been done wrong. It's right there. It hits the origin. It should not, because y equals 3 when x is 0. It should go through the coordinate 0, 1. Anything to the power of 0 is 1. So just, again, 1 mark, don't fill up 3 lines, keep it simple. But basically it shouldn't touch the x-axis. It should go through the coordinate 0, 1. Number 20, you know they're coming. You can't reach for your calculator because they've given you the answer. So let's hopefully work towards it. Always let x equal the decimal. Always bunch them up so that the recurring comes right up to the decimal, because you want that to be repeating. So you don't need 100x, you go to 1000x, because by timesing both sides by 100, the recurring every 2 digits budges up again. And now you can do a takeaway, because the recurring parts after the decimal point cancel. So 1000 take away 10, we get 990. And 123 point a load of rubbish, take away 1 point a load of rubbish is 122. Definitely show this next line. It's 122 over 990. Obviously you can use your calc, but the answer's right there. Divide top and bottom by 2. So for question 21, you could choose to combine the fractions. That's all perfectly fine. I prefer to multiply through by each denominator. So first one, the denominator disappears. 3 multiplied by the x plus 4. And on the right hand side, 1 multiplied by x plus 4. Then that's gone. I now need to multiply through by 2 minus 2x. Doesn't need it here because it just disappears, but it is required over there. So let's expand and simplify. Left hand side, that loop gives me 2. That gives me 12. So I'm getting 14. That loop gives me minus 2x plus 3x plus 1x. That loop is minus 2x squared. That's a plus 8. And then we've got x times 2, that's 2x, minus 8x, minus 6x in total. And now we make it equal to 0, because I'm not a fan of having negative x squared when I'm factorising, so let's get that across. Add 2x to both sides, 2x squared to both sides. Add 6x to both sides, taking away 8. AC method is perfectly valid, but because the 2x and x is compulsory and everything's positive, quite easy to have a little stab in the dark and a guess. So 3 2's are 6. Alright, so how can I make 7x? It's by having 3 lots of x, 2 lots of 2x. And so there we go. We've got it factorised. But don't forget, solving means it wants x equals. So one of the solutions is -2. And one of the solutions is -3 divided by 2. And there we go. Strange one for number 22. Kind of resembles a couple of other simultaneous equations questions you might have seen, and it is kind of that, but it's got the extra thing, it's parallel. Now, parallel means, yeah, it's in the relationship of 13/6, but it might be bigger, it might be smaller, or in other words, there's a multiplier. So when we read across the top, the horizontals, 2a and 8b is 13k, and then 6a plus 2b is 6k. There's your problem, because it's not just straightforward. You've got some numbers on the right hand side. We need to eliminate the k. We want b in terms of a, something over here. We've got to get rid of the k. So I'm going to take the top equation times everything by 6. So that will give me 12a and 8 6's 48b equals 78k times the bottom by 13. 13 6's 78a, 13 2's 26b, 13 6's 78k. So I'm going to do top take away bottom, means 12 take away 78, minus 66a, 48 take away 26, 22b equals nothing. We can now get b equals. We add 66a to both sides. We're nearly there. Divide both sides by 22. All that for something that looks straightforward, but only at the end. So we've got a circles question. As soon as you see the equation of a circle, definitely I would advise you just to acknowledge where the centre is and what its radius is. Now, me with an electronic pen, it's not a good mix, but still, a diagram always helps, because you can see what's going on. You've got the coordinate -3, 4. Now, I know mine's wonky, don't care. So you can work out the gradient of the radius. It's downhill, so it's a minus, and it's vertical over horizontal, -4/3. So we've got this tangent that Alex is on about. Well, tangents meet at right angles, so the gradient of the tangent is the negative reciprocal. All right, you might just do 1 divided by it entirely, up to you. So this tangent, it has an equation, and we know a little bit about it. We also know it goes through the coordinate -3, 4. So if we put those values in, 4 for y and -3 for x. On your calc, start with 4 and add 9/4. You get your intercept as being 25/4. Let's give myself a little bit more room. So we can now go a little bit further, that the equation of the tangent is y equals 3/4 x plus 25/4. The final bit of the logic is Alex says it crosses the x-axis at that point. Now, if you put those values in, you'll see that they don't work. You don't get two equal values. The left will not equal the right. So I suppose that's one way of doing it. I prefer just for the understanding side of things, to go a little bit deeper and remind you that the x-axis is where y equals 0. So we can find x by subtracting 25/4 from both sides, and we divide by the coefficient of x, divide it by 3/4. You end up getting the answer minus 25/3. In other words, minus 8 1/3. So Alex was close, but not spot on. So is Alex correct? Make sure you give it a no. On we go to the final question. Doesn't look very friendly, this one, but it brings you back to the principle of what is probability best written as, and that's fractions all day long, where the numerator is the ways of achieving success and the denominator is how many ways or how many outcomes are possible. So we'll come back to that. Let's now think about this line. X is the number of pink counters, Y is the number of counters. There must be more counters than there are pink counters, so you can start to think about the fact that the number of counters in the box, 1 to 3, and there we go. So for the rest of this question, instead of using the letter Y, I can straight away replace it with 3x. Now let's look at the colours. We've got X amount of pink, we've got 5 blue, and we've got some green. Now there's a total of Y. Well, hold on. That total is 3x. So the total is 3x. How many greens are there? Well, we need to take away x and take away 5. And that's the expression we can write for how many greens are in this question. We can now move on. Another fundamental idea of probability is with probability trees, when you move down the branches, it's multiply. When you want more than one branch, it's add. So let's look at pink followed by pink. So first pick, there are X amount of pink. Second pick, we go down by 1. In terms of number of counters, it's 3x. I know it's y, but we've replaced y. So there's 3x there, and there's 3x minus 1 there. And that will be common for all the parts, all the branches of this question. So on the numerator side, we get x squared minus x. And just a quick check of the question, it wants it in that form, so let's give it in that form. 9x squared minus 3x. We now move on to the easier bit. Blue, blue. That'll be 5 on top, and the second bit will be 4 on top. Or in other words, 20 on top. 5 times 4. And again, the denominator isn't changing. We then pick it up. The trickiest side, the trickiest part, green, green. Again, we're not too fussed about what's on the bottom. We know what's there. It's about what's on the top. So on the first pick, there are 2x minus 5 green, and we go one below, one lower is 2x minus 6. So again, not really fussed about what's happening on the bottom, but when we expand the top, don't forget it's a quadratic, it's 2x minus 5 times 2x plus 6. So I'm getting 4x squared, positive 30, and in the middle the x terms minus 10, minus 12, so minus 22x in the middle. So, answer once it's in this form, we're nearly there. The denominator has been there for a couple of minutes now. Let's look at what's on top. Let's do the x squareds, because don't forget, at the end of branches on probability trees, you add. So we're basically adding or simplifying the numerators. We've got 4x squared and x squared. That's 5 of them. Numbers wise, we've got 30 and 20. So that'll be 50. And in the middle, negative 22x, negative 1x, negative 23x. Easy peasy, really. So, not a very friendly looking one, but it does boil down to improbabilities. Fractions are best, and then they're easier to multiply and add at the end. So I really hope that's helped, and I'll see you on the next one.